And welcome everybody to the live stream. Hey, it's so good to have you here. Not only in the studio today do we have one barker who cares about you, but we've got two barkers. My son is here in town for the AWS conference, and I thought, hey, do you want to come over, have some dinner, go to a show? He goes, yeah. And I thought, hey, while you're here, why not join me for the live stream? So say hello to everyone.
Hey, everyone. Glad to be with you today.
So I've got 7 amazing kids, and Paul's my one of those amazing kids. I'd use the joke of he's my favorite, but that only works if I'm really in front of one of them. So if any of your siblings who see it on the video think, "Oh, you like Paul? I thought you loved me." I do. It's a secret. Okay, so I do have a question, and the question is this: would you like to have covered next week? So next week we're going to move to 4 p.m. on Wednesday. Next week, my question is, do you want ACLs, access control lists, or VPNs, virtual private ends networks, and or port security? That'd be layer 2 port security, not like San Pedro or, something like that, but rather like a layer 2 switch. Yeah. All right. So if you take a moment and chat in your preference on what you'd like covered next time, A, B, and C, A, B, or C, that'd be awesome. All right. So... today we're going to talk about dynamic ARP inspection. I'm so excited. My son's here. I had a really long day. You did too. You're in conference all day. And you've been going since Monday, right?
Yep.
Wow. So, your feet hurt? I'd offer... Never mind. So anyway, it's been a long day, so I'm so glad for the live stream. I want to talk about dynamic ARP inspection. So, because I have you here, do you mind... have we, for this recording... And for those people here, Gus and others who are here in the audience. By the way, that's Gus's picture right there.
I know Gus. I've seen him on your comments.
Oh, yeah? Okay, yeah. So he was in Vegas a while back. We went to lunch, dinner. Great guy. Great guy. So I keep a picture right there of Gus because it reminds me of why I'm here. It's like, I'm not just, recording hours and hours of amazing content for the, some unknown. I'm doing it for every one of you. And so I love it. Okay, that sounded really bad. All right. Have we rehearsed anything about DAI up to this point that you remember? Okay. I thought, I'm not going to preload it.
in blind.
Okay. So let me ask you a couple questions, and then we'll go ahead and do some videos on DAI after we explain why it's needed. In the early days when I started learning networking and systems and electronics, it really helped me to understand why. Like, why would you do this? So when I teach, one of the secrets I use is I often start teaching everything with a challenge or a problem that it solves. Like, here's this really cool thing. Wait, let's bring up a problem, get emotionally involved, and then here's the really cool thing that solves it. And that's just like storytelling. Varying your voice a little bit, up and down, high and low, dramatic pauses. and this is the audience. This is on the camera. They're getting my left-hand side here. I better hold on a second. All right, canned air, not just for systems anymore. All right. So, what do you know about layered? Now, Paul's a programmer, amazing programmer. I barely know the difference between cascading style sheets and something else that would be like cascading style sheets. I don't know.
And I barely know the difference between IPv4 and IPv6.
Fair enough. So wow, good one. Good one. So, Paul, why don't you explain just for a moment a little bit of kind of the stuff you work on, anything that's exciting or interesting for you as, somebody who goes in a deep hole and programs for hours. No, that's not what you do.
We solve really interesting problems at CBT Nuggets. Things like authentication.
Oh, I don't think I mentioned where you work.
Oh.
So Paul is a programmer for CBT Nuggets up in our Bend, Oregon office. So he happens to be my son, and he also happens to be a programmer for CBT. Sorry, go ahead.
Okay, so we solve some really interesting problems like authentication, getting people use the right users, the right credentials, things about creating accounts, and all these problems are solved with microservices. And I'm a Node.js developer, but we do full stack stuff on my team. So everything from the back end, from servers to front end, websites, React, all these fun JavaScript topics that that I get to live in every day and solve these really cool, interesting problems.
Very, very cool. And you were part of OAuth and SAML and all that cool stuff.
Yep.
It's right up your alley.
Yep. Google,
all right.
Google sign-in, all this good stuff. Yeah,
okay.
It's like super exciting.
All right, yeah, you're good at it, and he's thrilled about it. So that helps make a career go fast, right? And as far as like if you enjoy it, you really get into it.
You have to love it. I mean, I don't consider my job work.
Really?
I don't. It's just so much fun. I look forward to working with my team every day. We get to solve puzzles and create cool stuff.
That is so cool. That is so cool. I have a joke that you may or may not have heard. So if you already heard it, just tell me and I'll stop.
Okay.
Do you know why Java programmers wear glasses? You've never heard this?
I've never heard this.
Oh my gosh. The reason that Java programmers don't wear glasses is because they don't see sharp. Or they do wear glasses. They don't see sharp. I flubbed it up on the
I just botched the delivery.
Yeah.
Wait, no, it's a good joke.
Okay.
I just haven't been in Java that long.
All right. Okay, so getting back to networking and dynamic ARP inspection, the topic of our chat, and I'm going to share with you three short videos on the concepts of it, how to make it work, and how to verify it. So stay tuned; those are coming up real soon. So, are you familiar with layer 2 addresses on networks?
No.
I see. I thought everybody was born knowing this. All right, I'm sorry that missed. So the way it works is, I'm going to borrow this wireless router. So this wireless router, inside it has a network adapter, and every network adapter on Ethernet has a 12-digit address.
Is that the MAC address?
That is the MAC address.
Okay, I do know what a MAC address is.
Okay, there we go. So that MAC address is 48 bits long. It is 12 digits long in hex to make it easier to represent, and they're all unique. So the first 6 digits of the hex are assigned to a vendor, and then they are responsible to make sure the last 6 are unique. So yeah, layer 2 addresses, MAC. That's the tricky part, is that there's like 5 different names for that Ethernet address. You ready?
Yeah.
It's like my shop teacher in high school. Yeah. I won't do that because there may be somebody. Okay, so there's like 5 I think of. There's the physical address, the layer 2 address, the MAC address, the hardware address. I think I can do one more. Layer 2, physical, MAC, hardware, burned in address. I'll take that too.
What?
Because it's burned in from the factory.
Burned in.
BIA. Sorry, I got so excited. Address. So I keep this jar of letters. Let's tell you all my secrets here. This is like to make a necklace or like a bracelet. I got them at Michael's. And the reason I have these is that when I record, I need to be heard, so I have to elaborate and have to be very clear with my words. Like when you and I talk like this, how you doing? It's like, that doesn't fly for recording. People want to hear, right? Especially if English is not a native language. It's tough. All right. So here's the challenge with layer 2 addresses. That devices on a local network. You want to play network?
Oh, that's fun.
Oh, yeah.
Is that a switch?
Yeah, it is a switch. Say hello to my little friend. So this is a multi-layer switch, actually.
Oh.
Yeah. Multi implying more than one.
Yeah.
So
routing and switching?
It does. Look at you. So a multi-layer switch has the ability to do routing based on layer 3 addresses, like IP addresses. Like, hey, we need to forward this to a street over there. How to route. And then it also has layer 2 forwarding, like a layer 2 switch based on layer 2 MAC addresses. So here's the key. Let's say that we're both plugged in. Will you grab? I've got a whole bunch of cables right there in that Ethernet box. Just grab your favorite color.
This is all Ethernet?
Oh yeah, it's a console cable, but that's totally fair because it's in the box labeled Ethernet. My bad. That's a rollover cable. So pin 1 goes to 8, 7 to 2, etc. And that goes to the console port right here on a network device.
Oh.
So what you do is you take a USB adapter to that port to here to initially bootstrap a device. Yeah. All right. Yeah, that's good.
No USB?
No. What is it? Question was, does it have a USB port? And some of them do. This one does not. This is built like 6 years ago. So.
That's probably right. This is what you're looking for.
Yeah, that's great. Okay. And we'll keep the black one too. That's great.
Awesome.
All right. So they may not, I don't know how low this is going to go. I'll just hold it up. All right. So I'm going to be white.
Okay.
You hold it for me? Thanks. Woo-hoo. All right, are you gonna be blue?
Yeah.
All right. We're gonna make this work. It's gonna be amazing. Here you go. Anywhere you want. Okay. Awesome. All right. So the way, and then we'll put the attacker right here. There's a. Wait, I'll just hang him off to the ground. So black would represent the attacker. Okay. Awesome. And hopefully you can see that black, but it's going down. Yeah, I'll put it up here on this part. So the switch learns all the layer 2 addresses. When we send frames in the network at layer 2, it looks at our source MAC address and says, oh, Paul, you live off this port. And Keith, you live off this port. And the hacker's address, he lives off this port, layer 2. So when a frame goes into the switch, it can forward based on exactly where it needs to go. Super duper. Now, the challenge is, if you and I want to talk to each other on the network, you want to play server or client?
I'll play client.
Client, okay. And I'll be a server. I'll be could it be a web server?
Sure.
All right. So you're making a web request using the application layer service of?
A browser.
Yes, the browser is a program using, what's behind the scene? What protocol is it using?
HTTP.
HTTP, and we had no pre-collaboration. Boom. So you're using HTTP as application layer service. Now the transport layer, which you're not responsible for knowing, it uses TCP, connection-oriented, reliable. And then as it goes down to layer 3, it's based on IP address. So what IP address would you like?
1.1.1.1.
Nice! 1.1.1.1. Let's assume a 24-bit mask.
Okay.
That'll work. Okay, and so basically with the 24-bit mask, it means that you're on the 1.1.10 network, and your host address is .1. Yeah, nailed it. So I'm going to be 1.1.1. That's the network part, and then I'll be .2. How about that?
Okay.
All right. So let's imagine that I'm the server, HTTP, you're the browser client, going to make a request, and it's going to get encapsulated on the protocol stack, and then there's going to be bits spent on the wire that include my destination layer 2 address, my destination layer 3 address, IP, and then once I open that up, I de-encapsulate, say, oh, it's TCP, great, and I de-encapsulate, HTTP request from Paul, and then I respond.
That's all this guy's doing?
Well, this is just as a layer 2.
Oh.
Yeah, the cool thing is every network device has to decide how they're going to forward. So you sent that whole information to request, HTTP, TCP, IP information, layer 2 information, then bits. You and then what the layer 2 switch does in layer 2 switch mode, it looks at the layer 2 destination address and forwards it to the right port so that device can get it. So in theory, a layer 2 device only looks at layer 2 and below. Yeah. If it was a router, it'd be looking at.
Because it's multi-layer.
Yeah. So if it was a routed interface, you're on a different network, you'd be looking at layer 3. Yep. All right, cool. So, so if you want to send that frame to me, how do you know what my hardware address is, my layer 2 address?
I have to ask.
All right. So nothing gets past this kid. So he has to ask. And the way we ask, do you know how they ask? You're not responsible for knowing this yet. Okay. It's called, let me ask the group. How does a device on the network like Paul find out what another device on the same IP network, same VLAN, what that other device's layer 2 address is? So if you would type that in, give you a few moments. And I got this really cool music. I've been feeling so small. Watch the clock ticking off the wall. All right, I could listen to that a long time. Good stuff. So that is a subscription I have to, I think it's Epic Music.
Yeah.
It's all that music I can play on YouTube.
Royalty free.
Well, yeah, they address the royalty. Yeah.
Nice.
Yeah, thanks.
It wasn't bad.
Oh, thanks.
Yeah.
Okay, boomer. Got lucky. All right. Thank you for your responses to that. And the answer is we're going to ARP. So basically, you send out a broadcast, a layer 2 broadcast. The switch sends that to every other device in the same VLAN. And
so it goes from me to the switch.
It goes from you to the switch, this ARP request. And the switch says it's a broadcast layer 2 address. It takes all the other ports in the same VLAN and forwards it. So everybody, it's like going into a crowded room and shouting, "Hey, listen!" And everybody goes, "What?" And then they all listen. And then you're saying, the person who has the IP address 1112, I need your layer 2 address. So I heard that, and because I do have that IP address, I respond, and then you now have my layer 2 address. Ta-da! ARP. It's a wonderful thing. Now, let's introduce the attacker. The attacker can do something called, what's the word it's called? Lying. It could send me a packet, an ARP request, or send you an ARP request and say, hey, Paul, to get to the layer 2 address associated with 1102, the server, it's really this MAC address. And if you believe that, guess whose MAC address he just gave you? His. And so the switch, when you send frames to me at my IP address with the wrong layer 2 address, it's going to forward the switches out the wrong port, and the attacker has now eavesdropping capability on your traffic. It's nasty. And it's so easy to do. So easy. And then the attacker, what he's going to do is he's going to he's going to re-forward it to the server to me. Oh. So I got your frame. Yeah, great. Except he's the source MAC address of him. So I respond back. He's lying to both of us. It's bad news. We can disengage from the network now. But that's what ARP spoofing is. Layer 2 man-in-the-middle attacks. Not good. So the question might come up. Well, Dad. That's not how Paul talks. Anyway.
Well, Dad.
Well, Dad. So how do we prevent something like that? The answer is DHCP snooping and a concept called dynamic ARP inspection. And I think to best describe that and explain that would be to roll the tape. Is that okay?
Yeah.
All right. So let me bring up my screen here. Also, thank you for your votes earlier about what you'd like for next week, whether it's ACLs, VPNs, or port security. And let me launch. We've already talked about why it's needed, right? So let's go ahead and launch this one, the recipe and commands for dynamic ARP inspection. From the previous video, we identified that a device lying in ARP messages about layer 2 address information is bad news for the network. So we're going to solve it with dynamic ARP inspection, DAI. So in this video, let's take a look at the syntax for how we would apply it, and we'll also have the opportunity to talk about the concept of a dynamic ARP inspection trusted interface as well. And let's use this topology as our backdrop for the discussion for dynamic ARP inspection and how to implement it. So we'd start off with a switch that supports dynamic ARP inspection. It has the feature set. And one of the questions that we ought to ask ourselves is, well, if the switch is going to check on the ports for ARP messages and make sure that the correct layer 3 address is mapped to the right layer 2 address, how does it know? That's a good question. The primary way when we implement this that the switch is going to know what the corresponding layer 3 and layer 2 address is from the DHCP snooping. So unless we want to manually configure all of the mappings for all of our clients with this IP address and this MAC address, we'd want to rely on DHCP snooping. So it's pretty cool that information with DHCP snooping can be used by dynamic ARP inspection for the ARP checks. So we have a router that's connected to a switch. There's a trunk here, which implies we may have some multiple sub-interfaces here. And then from the switch, we have a couple of ports. Gig 0/1 is associated with VLAN 30. Here's the subnet of 10.16.20.0. And to implement dynamic ARP inspection for VLAN 30, here's what we'd do. We'd use this command in global config. IP space ARP space inspection space VLAN space 30, press enter, boom, and it's applied. Now every ARP message that goes into the switch is going to be checked. It's going to say, hey, is that the correct layer 2 address that you're advertising or you're responding with based on your IP address? And if it's not, it's going to deny that ARP message from entering the switch. Now a really important question is, how does the switch know? How does the switch know what the corresponding IP and MAC addresses are? It's a good question. And one way, and the most popular way of implementing this, is by using DHCP snooping also. See, if we use DHCP snooping, which we covered in a separate skill, it's going to listen to DHCP messages, and it will dynamically build a table that has the IP address and the layer 2 addresses. And now DAI, Dynamic ARP Inspection, swoops in and says, great, I'm going to use that table. Thanks, DHCP snooping. I'm going to use that table as I verify the responses in MAC addresses to make sure that nobody's lying about their layer 2 information. That's how it works. So although it's possible to configure all of our devices, their layer 3 and layer 2 information manually, the most popular way is to also include DHCP snooping, and that will capture all the layer 3 and layer 2 mappings for our DHCP clients. Now, what about devices that are not DHCP clients? Like router 3, it's not a DHCP client. What do we do there? Well, we can manually, statically configure the layer 3 to layer 2 mapping and tell dynamic ARP inspection to use that, or we could specify this port on the switch where R3 is connected as a trusted port. And so if R3 is associated with VLAN 30, but this port is a trusted port, the switch says, ARP messages coming in that port, not going to check. You're free and clear. Have a good day. While at the same time, all the other ports, which are untrusted from a dynamic ARP inspection perspective, all the other ports will have their ARP messages checked for the correct layer 3 to layer 2 mapping. So if we wanted to configure interface 3/3 as a trusted port, we'd use this command right here in interface config IP space ARP space inspect space trust, press enter, and no more checking on interface 3/3. And if we wanted to verify that dynamic ARP inspection was applied, we could use the command show IP ARP inspection VLAN and then the VLAN that we want to look at. So in this video, we've taken a look at the commands to implement dynamic ARP inspection, and in the next video, you and I get to actually apply it and verify it on a switch. So I'll see you there in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing. All right, and while I queue up the other video, we had a tie between ACLs, that's access control lists, and VPNs. So if there's any final votes about if somebody didn't vote yet and still wants to, you could be the tiebreaker. If there is no tiebreaker, Paul, I'm going to come to you at the very end and ask you what you'd prefer.
Sounds good.
All right. And then you can fly down for the next live stream. Love to have you. All right, here's the next video. Welcome back. In the previous video, we took a look at the syntax, the commands to implement and verify dynamic ARP inspection, and it's now time to put those commands to work. Let's take a look at our diagram, and then we'll go to the lab. So here's our plan. We're going to implement dynamic ARP inspection for VLAN 30 on this switch, and the command is IP ARP inspection VLAN 30. And to set this interface 3/3 as a trusted port, we'd use the command in interface config on the switch, IP ARP inspection trust. Then we can verify our work with the show IP ARP inspection for that VLAN. And as we jump into the CLI, I've got a question for you. I know that dynamic ARP inspection is going to check the ARP messages just to make sure that nobody's lying. Well, it has to know what the correct layer 3 and layer 2 combos are for each of the hosts. Do you recall where it's going to look to see whether or not the layer 3 and layer 2 information matches up? What is the other source of that information that it's going to pull from? Do you remember? And if you're saying keep... All right, sneak attack. I put the video back on. My question is, how does it know? What is the method that we talked about in a previous stream and also earlier today that gives a mapping of the layer 3 addresses and the layer 2 addresses that DHCP, that dynamic ARP inspection, that dynamic ARP inspection can look at? So if you recall how the switch can dynamically learn the layer 3 and layer 2 mappings, type that in, and then I will continue this video. And I'm going to rely on Jake to go ahead and read those into me. Fantastic. All right, and the video continues. I think it was DHCP snooping. You are right. So the first thing we're going to do before we start configuring anything is we want to verify if DHCP snooping is enabled and see if there's any entries in the DHCP snooping binding so that ARP inspection has something to work with. That's really important. So let's take a look at that first. So here on the switch, let's do a show IP DHCP snooping, and we use the keyword binding. Press enter. And sure enough, we've got 2 entries. We're concerned with VLAN 30, so it knows at least one here. This MAC address with this IP address is on port gig 0/1 in VLAN 30. So once we enable dynamic ARP inspection, it can use this entry here as a way to check to see whether or not the layer 3 and layer 2 information is correct for a device. We also should do a show IP ARP inspection for VLAN 30 just to make sure it's not yet configured. So that's a great starting point for us. It's not yet enabled. So let's enable it. We'll do a config T. And I've got a question for you. Let's go back to our topology for a moment. Should we make this a trusted interface first before we enable the feature for the VLAN? I'm thinking we should. Otherwise, we're going to get errors anytime R3 does ARP messages because R3 does not have a dynamically learned address. So it's not in the DHCP snooping binding table. So I would recommend we make this 3/3 interface trusted first, and then we enable the ARP inspection on VLAN 30. So we'll go to interface gig 3/3. And also, we should verify that we're on the right port. I mean, how do we know that interface gig 3/3 here on the switch connects out to R3? And one way of doing that would be a do show CDP neighbor. And that's going to verify it for us. So our local interface gig 3/3 does indeed go to R3. Fantastic. So here, we'll do an IP ARP inspection, question mark, and trust, and press enter. And then we'll enable ARP inspection for the VLAN with IP ARP inspection for VLAN and 30 and press enter. Then we'll type in end and we'll do a show IP ARP inspection for VLAN 30, press enter. And check this out. We got a lot of activity going on here. So we have a lot of denies going on here, and they're all coming in on gig 0/1. Look at the IP addresses. We have 10.1.0.111 and 10.1.0.120. Let's talk about why that's happening. And here's what's going on. Off of this one port, I've got some other devices on the 10.1 network. So although it's one broadcast domain down here, I've got different devices with thinking it's different subnets. So I've got some devices on 10.1.0 that are sending ARP messages, and they're working their way up to this port because they're broadcast based. And the switch is saying, nope, I don't have any information in the DHCP snooping table that says this specific IP address of .111 or whatever it was. And because I can't verify it, because I don't know, I'm going to drop you. And that's what those messages are. So what we've done is we've applied ARP inspection for VLAN 30. We made 33 a trusted port. We also did a show command to verify that it's configured. But now our challenge is we've got some ARP messages from other devices off of this port down here that are being denied on this switch port. And that provides a perfect segue for the next video, because in the next video and lab, what we're going to do is we're going to take devices that are not being learned via DHCP snooping and create static entries that basically tell the switch, you know what, this IP address and this layer 2 address, they match up. Go ahead and use it, even if it's not in the DHCP snooping table. And as a result, by looking at that list and saying, oh, yep, these match, the dynamic ARP inspection can check on ARP messages even though they haven't been learned via DHCP snooping. So we'll do that with a ARP ACL in the very next video. So we'll see there in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing. All right. And guess what the next video is on? It's like sneak attack. So in the next video, I'm going to walk them through, if you have clients that don't have a DHCP address, they didn't. Are you familiar with DHCP? Mm-hmm. So if they didn't dynamically learn with DHCP, they're not going to be in the snooping database. If they're not in the snooping database, dynamic ARP inspection can't check them. So we can create either trust the ports, or we can actually create an access list. Yeah. Basically, the access list says, and this is the next video, it says, here's their MAC address, here's the IP address, use this as well as your DHCP snooping. That's how it works. Yeah.
I see. So if you statically assign your
Yep.
IP,
Yep.
it would be part of that.
Exactly. If you statically assign the IP address, you could either trust the port, the switch port, and simply say the device hanging off of this port, it's a DHCP snooping trusted port. I'm sorry. It's a dynamic ARP inspection trusted port, and then it won't even check.
Okay.
Yep. And because DAI, dynamic ARP inspection, and DHCP snooping are so closely linked, when I think of them as like one
Same thing.
combination of tools that work together. Sort of like microservices. Yeah. All right. Do you have any questions about any of that? Did you learn anything there? Or?
Oh yeah. It answered the question is, if I'm trying to get an IP address from, like, say, hotel Wi-Fi, and then I have another device trying to get internet through that other device,
Yep.
It's going to get denied.
So we could have a whole separate discussion on that, because I can show you how to do that with a thing called NAT, Network Address Translation, Port Address Translation. But a lot of companies have the features of dynamic ARP inspection, and they don't use it. It's like, wow, it is just so easy to throw on like a Kali Linux box. I've got a Kali Linux box on a little Raspberry Pi. I've got one on the wall there, and I've got another one in there. Anyway, are you familiar with Kali Linux?
Mm-hmm.
Anyway, it's just
from your penetration testing course.
Okay, so you plug this thing in, you launch the command, and it'll spoof. You put in it just spoofs everybody. Says I'm it.
Yep.
So people going to their default gateway would be going to you, and vice versa. Anyway, nightmare. All right, nightmare if you don't fix it. Okay, next week, 4:00 Wednesday. What we're going to do is we are going to do VPNs, because there was a couple of late votes that said VPNs. So that will be our topic. I'm going to cross out everything else besides that, so I remember. Also, I'm going to move up this live stream on the individual skills for Wednesdays at 4 p.m. Pacific time. And I'll be sending out notices as well. As also, in fact, I just decided today I'm going to do it. I'm going to create a little live stream, and it's going to be based on that. The new CCNA, the 200-301. There's a lot of crossover with the old one, And I thought, I could just cherry pick like the core topics I think are really important for most people to get. It's like programming. When a person starts to learn some basics of how it works, then it just grows from there, right?
Mm-hmm.
Like, variables, I get it. Call the variable, set the variable, call the variable, things like that.
Yeah.
The same thing.
Your little tool set. You build tools based on that tool set, and your tool set grows.
Yes, same thing with this. Same thing with networking. So I'm going to create a new live stream. I'll send out a post for it. I'm going to call it CCNA. I wrote it down. CCNA Sundays, or CCNA Sunday with Keith Barker, or the OG. Hey, thanks for wearing my shirt today, by the way. so kind of you. And I'll probably have it at 11. I'll send out a notice at 11 a.m. 11 a.m. on Sundays. That way it gives me a chance if I go out that night, I can still get some sleep. And oh man, I had a really long day today, so I'm super excited to chat with you. But I'm ready also to have a little relaxation. But I learned, I did a podcast with a friend, and it was like 7 a.m. my time, and it was not great. I was like, it was so bad, in my opinion. I was like, I didn't want to even listen to it because I knew I was groggy and tired. I just woke up, So anyway, I don't do anything like that before 11 anymore. So CCNA Sunday is coming to this YouTube channel. I speak for a living. I do. Coming to a YouTube channel soon. If you have not yet subscribed to the Keith Barker networking channel here at CBT Nuggets, please do. We'd love to have you join the community. I always appreciate people who answer other people's questions based on the videos. It's always helpful. I usually go through like once a week and look for things that have not been answered where I can answer them. I did a video for a little 4K GoPro competitor, a really inexpensive one, and you would not believe how many questions I get about that camera. Like, how do I connect this to my computer? So I'll help them out whenever I can. Send them a link. But yeah, that's not really my wheelhouse. I mean, I love cameras. This is my. Have you seen this one?
Mm-mm.
This.
Is that the 360?
This is the 360 camera.
No way. It's so
right
small.
there. I know. And then that stick right there.
Yeah.
Is the invisible selfie stick. It erases it from the picture. So you just hold it up. I was in Europe. I just held it up, and it's super fun.
So what's the app that you use to view the videos?
Great question. They have one.
Okay.
So use the app.
The
So you can either download it, just plug it into USB, download it to Adobe.
Mm-hmm.
It's got a plug-in for it.
Oh yeah.
So you can do it right there. Or you can just download it to your phone, and then you can upload it to social media from your phone. They're quite fun. All right. Let's see here. I talked about the topic next week, which is going to be VPNs. I mentioned that we are going to do CCNA Sundays, covering a lot of the cool stuff from the new blueprint for CCNA. I introduced you as my son. Thank you for being here.
Happy to be here.
Where do you want to go for dinner? Tell me later, right? Okay, in a few minutes. It's like, Keith, we still have people on the stream. We talked about dynamic ARP inspection today. It's a really important tool that a lot of companies don't use. They've got the gear, but it's important to turn on. And one thing about dynamic ARP inspection is that you want to be aware of devices that don't have dynamically learned addresses you might have forgotten about. Especially the Internet of Things, there might be static addresses. And if you forget about just one of them, you're going to get that message.
So my question is, how would you actually be the attacker? Would you have to physically attach yourself to a layer 2 device?
Oh, let's do it. Okay, so with or without dynamic ARP inspection? Without.
Without.
Okay.
Yeah.
So let's say the black cable still is the attacker. What color did you have before? Blue?
I was blue.
Okay, no mind.
Yeah.
So what would happen is and really when we say the attacker, it's any computer that's already connected to your network that wants to run malicious software.
Oh, I see.
And you're done.
Okay.
Like Cain and Abel's
Sorry
going
there.
way back. Yeah. So they've got the connection, or they disconnect it, they put a switch in,
Mm-hmm.
and then they add another device. It's also possible.
Okay.
So one great method, which is way beyond CCNA, but it's awesome, is using 802.1x authentication. Woo, big words. Big letters, and big numbers and a letter. How about that? 802.1x. That is a letter. All right, so with 802.1x, we basically authenticate the device before we allow main traffic to go through. So your computer, would connect, it would have what's called a supplicant, and that supplicant would be able to talk to the authenticator, this device, and verify who you are with a backend like a Radius server. And then once the device has been verified, I know who you are, and you're cool.
You can have traffic.
Yes, and that's really, with all these ports that go out to cubes and offices, That's really the only way to make sure what's connecting to your network.
Yeah.
Yeah. And then short of that, though, you could have a device that is authenticated and then doing network sharing to another device. But then you could have group policy that can control that.
Mm.
So it's tricky. You got to stay one step ahead.
Yeah.
All right. Let me just check. I've got Jake, who's been so great helping me moderate any questions that haven't been answered. Jake, if you would, let me know if there's any additional questions. I'll put some music on for just a moment, and we'll take any final questions. All right, thank you, Jake. There's no additional questions. The VPN's beat out. Port security got 0 votes. We don't want it. So at layer 2, there's 3 major tools that we should or could be using. Port security, that helps verify that no more than 1 MAC address or 2 MAC addresses show up at the port. Mm-hmm. So we don't have a problem there with flooding or mischief. The second would be DHCP snooping to protect against rogue DHCP servers. And then as a result of that, the table, we use dynamic ARP inspection. Those are winners. They should be used. All right. If you haven't already yet, I would love you to subscribe. Make sure you get the alerts when the new streams come out. If you have a friend who's considering getting into the world of Cisco or entry-level networking, that's my forte. I love it, just like you love code. I love networks. They're because they're like puzzles. They really are. It's like, oh, how do I make that work? And how do I protect this network? And how do I get the routing to work and the switching to work? It's a lot of fun. Do you know much about trunking?
No,
all right.
Nothing.
All right. I'm going to save that for another video. All right. Hey, thanks, everybody. Have a great rest of your evening or whenever time you're looking at this, the rest of your day. And we'll see you in another video here on Keith Barker Networking on YouTube. Thanks, everybody.